speakers were talking about IoT and means deployment of sensors everywhere along the in industry in everywhere. So those sensors actually send you some data, right? So what happens with that data after that? Like what do you do with that data? Okay. So we actually can feed those data to these AI models, and those model will help us predict any future failure. Suppose let me give you an example. At Tata Steel, we have made our own vibration sensor from scratch, basically. So that vibration sensor, what it does is it takes data from motor drive and non-drive, and we'll come to that tomorrow when we have another session. There I will talk about how we have made that vibration. Now, this vibration sensor, it just sends data via Wi-Fi to a secure server. Okay. In that server, you have all the data you want. Now, what we did was made an AI predictive model that we have told the model, we have given them instructions that if this is the signature of the vibration, then it can be a bearing failure. If not, then it is some other failure maybe. So we actually have, and now AI can predict for us, like if we are getting this kind of vibration signal or a signature, then we can find out that okay, maybe the motor is having a gearbox failure or maybe a bearing failure or anything. Okay. So basically in Tata Steel, we need it for optimizing this plant scheduling and operational costs to be reduced. So what does plant scheduling means? Like we have to plan the downtime. So in any certain point of time, the production stops because of maintenance. We face huge losses because of that. So we have to plan that activity so that we face minimal losses during that time. So AI helps us in that. So AI helps us predict when you need to do your maintenance and when you can plan like the entire means if one plant stops, the other plant should not stop. We have to plan that like that. So AI helps us in scheduling these things and reducing our operational costs. Okay. Like I also said, like motor predictive diagnosis analysis. So, like I said, these vibration sensors, the temperature, if it increases, there are acoustic signals also which we get from acoustic sensors. So from there we come to see that okay, okay. So early indication of a motor failure comes from sound basically. That's why we use acoustic signals. In this acoustic signal, we come to know okay, this motor might have some kind of failure. That helps us in repairing the motor in early stages so that we don't need the whole cost of replacing that motor. Again, helps in costing. Okay. So now let me tell a few words about everything, like basically AI, what is AI, what is NLP, what is PV, ML, DL, and RL. What are those? What is ML? ML is machine learning. What is it? I'll come to that. Yes, correct. Because this application. I understand. Correct. I'm coming. Oh, yes, coming to that. So AI stands for basically artificial intelligence, which is basically a machine trying to imitate a human behavior. How? I'm coming to that. How is it imitating like a human behavior? Okay. So machine learning is basically a subfield of AI, as you can see here, and that is the ability to learn from the data basically. So we have huge amount of data. You feed it into a model. You tell them that if there is this kind of input, we are expecting this kind of output. Okay. So basically, if you help the model understand, you run it multiple times. So help the model understand. Like if this kind of input, the accuracy will be very low at the beginning. Okay, we'll see some examples also. We have the code written as well. No, I am not interested in the different application. I am interested in the application of machine learning according to the AI. Correct. And which principle be applicable for AI. No, that is important. No, I'm sorry. Which principle you mean? Which principle of the machine learning is applicable for AI? Machine learning has number of algorithms. Correct. And three is important. No. AI is the broader aspect. You cannot like machine learning. Now this time AI totally depend upon the machine learning and deep learning. Correct.
Okay?
Correct.
But this machine learning is depend upon some algorithm.
Correct.
And that algorithm is important for the AI.
Correct. Correct.
So what is the actual issue?
So you want to know what is the relation between ML and AI?
Which application be applicable for AI with help of the ML algorithm? This is important.
Okay.
All our the member is curious about this information.
Correct.
Not the application. Application available in YouTube.
No. Okay, understand that. But my agenda for today was to show you what we
You
use.
have agenda,
Correct.
right?
Yes.
And you see that is
Yes.
the relation is important.
Understand. Okay. Okay. So basically, what is NLP as well? So NLP is basically called as natural language processing. So if you have seen Google text to speech or like speech recognition, these are the some kind of applications where NLP is also used. Okay. Reinforcement learning is something different. It's like the machine learns from its own mistakes, basically. It learns from its own mistakes that, okay, this is the accuracy is less. Why? Because I have taken the wrong inputs, maybe. So it changes that inputs to fit its model, basically, and we get a better result.
That's part of that propagation.
Correct. Yes. So back propagation. Yes, correct. So basically, in reinforcement,
that propagation depends on two parts. One is the supervisor, the non-supervisor.
So supervised learning is more important.
If the supervisor is target,
Yes, input. You get an. Hmm. No. Yeah, I didn't understand. Yeah. Hmm. Hmm. Hmm.
AI.
Okay. Okay, I'll come to it maybe. If I have it in my agenda, maybe I will come back. But I understand your question, but maybe I don't have the answer to that right now. Hmm.
हम लोग एडवांस इंडस्ट्रियल बहुत एडवांस चल रहे
Correct.
हैं तो हम चाहते हैं कि वो एडवांस एप्लीकेशन हम लोग को भी पता चले
Hmm. True.
उस चीज की बहुत इंपॉर्टेंट है
इंडस्ट्री में क्या यूज करते हैं ना सो आई विल शो यू व्हाट वी यूज इन आवर इंडस्ट्री आई कैन ओनली शो यू काइंड ऑफ एप्लीकेशंस राइट नाउ सी इफ आई go into the deep understanding no it's not possible in this 1 hour session basically correct I don't think actually maybe yes so
It's just all putting this line.
no, my main target would be ML and deep learning, ML and DL most. So NLP, NLP, CV also I will cover a little bit. CV also mostly CV in image processing we will cover. Computer vision basically image processing to identify. Maybe if you see get an image of a cat and a dog, how will you identify that this is a cat or this is a dog? If you get a image of a flower, how will you identify this is a sunflower?
Image not always give the accurate value. If you take the Xerox, again you keep the Xerox paper, so not the same color which me.
Correct.
Something is that.
Correct. So accuracy will never be 100% of the model.
We are using natural language. I mean.
No, NLP. I do not have any application where we are using it.
For detecting cat or dog, so.
No, not NLP. No, we are using CV computer vision. We are using. Okay.
So basically, is it RL is just like ChatGPT? You are saying that it is improving itself. So nowadays we are using ChatGPT.
See, RL can also be like I think you have also mentioned. I think RL can also be unsupervised, maybe. Okay, so see there are two types of learning: supervised learning and unsupervised learning. In supervised learning, you give the labels of every input, labeled inputs you have. Okay, in unsupervised learning, you don't have any labeled inputs. Labeled means you tell them that this is like the like flower category. This is coming from the flower category. In unsupervised learning, you cannot. There is nothing written about flower. It's just simply written. Is it a daisy flower? Is it a sunflower or something like that? It never mentions that it is from the flower category. In supervised learning, it says that it is from the flower category. We have daisy, rose, or any other flowers they have written. So we have put a label flowers on top of it so that the model understands that it is coming from there. Okay, in unsupervised learning, there is no label data. So basically, there are lots of things written, and the computer sees it and it has to understand it somehow from the web. That I cannot go into. I have never introduced it. Okay, so I think we have talked enough about machine learning, maybe. So basically, how it works is basically there is a decision process, there is an error function, and there is a model optimization process as well. So decision process is basically like the machine learning algorithms where a prediction or classification. Basically, we'll make a prediction or a classification. It works on probability basically. Okay, so we will estimate a pattern about all the data. So after we make a model, we will find out how much error we got, what is the loss value, what is the prediction value we got. Okay, then after that we will make the model optimization process. Model optimization process is taking into account this error function and everything. We will again train the data set on that same algorithm and we'll get the desired output. The accuracy will increase or decrease according to that, and we have to learn from that. Few ML algorithms are there as well, like regression, clustering, decision trees, neural networks, and SVM. I can go into every thing of them, but it will make it a very long session actually. But still, I would say one line about it basically. So what is linear regression is basically a supervised learning algorithm that predicts a continuous output variable based on one or more input variables. Okay, so this is the basic simple model that everybody uses, I guess. Okay, so logistic regression is again a supervised learning algorithm which predicts a binary output variable based on one or more inputs. So logistic understands that. Right? Okay, decision tree is a supervised learning algorithm that splits the input into branches of certain conditions. Okay, like is it an animal? Yes. Then if is it a cat or a dog, like that, it branches from. Okay. So there are other means also. From unsupervised learning, there is a k-means clustering. So in k-means clustering, what happens is it partitions the input data into clusters similar to that. Maybe it found roses and from the flower something he found out like roses and daisy somewhere. So he made a cluster there. It made some cluster there, but it found flower names here, so it made a cluster here. It found flower names there, it formed a cluster there. But how to link that we have to teach the AI again. So that is one more process that comes in unsupervised learning later on. Okay. So basically, this is how what deep learning looks like. You see an input, you see an output, but in between, what you see is a hidden layers, basically what we call artificial neural networks. Okay, this artificial neural networks is more or less similar to how our brain functions, like how we have neurons, dendrites, axons, how it works. It's almost similar to that. So every layer is connected, interconnected between themselves, and finally find the output from it. Okay. Now this is what happens. Like we give an input. It basically processes it. In basically in neuron, what happens? We get electrical signals, and when it goes to the output, we get one more electrical signal that may be fed to another DIM. Okay. So in artificial neural networks also it's the same thing. Okay. When do we call like it's the deep learning? Deep learning. So when we have two or more hidden layers, we will call it as a deep learning. Two or more artificial neural networks or hidden layers we have, then we'll call it a deep learning. Okay. So artificial neural network is something like you will have one or two, at max two, I think you have hidden layers in between or interconnected layers in between.
Okay. What is the purpose of hidden layer?
So hidden layers is basically, it contains your interconnected, like I'll tell you in images when what happens is in between the images, it will give you filters in between, and it will like like how a light passes through a filter through it will like identify whether it is a sunflower or not. These hidden networks are mostly like inputs and outputs and interconnecting between themselves so that it understands.
So what's the process? This is not process. One where they have number of neurons and number of neurons connected to each other.
Correct.
They have some threshold, and that threshold calculations leads the relation which types of signals will go there or not.
Correct.
So that is
So there is a weighted sum actually. Yes. So okay, I'm coming.
And after that, filter the particular condition. Will be okay. So that
Correct. So there's basically they can coming. This is called a weighted sum. What we called as a weighted sum. It calculates or a weight. It adds to every value that comes out of it. It adds the weight.
that.
Yes.
Weightage is calculated by which method and what is the threshold. Can be calculated the particular specific one.
Correct. Yes. So
after that we decide this specific one will be done by that principle.
Correct. Yes, correct. So I'll come to the weighted sum. How means maybe not how it is calculated, but it depends on the weighted sum basically, and what is the weight actually. So maybe we move on. So yes, so this is what we called as a neuron and a perceptron basically. So like I said, this is a human neuron, and how it connects is via the electrical signal. And in perceptron, it is a type of artificial neural network that is inspired from this biological neuron basically. Okay, and so a perceptron contains a input layer and a processing unit and an output layer. So this processing unit is what we called as a between a hidden layer or some or that. So in actual neuron, the dendrite receives the electrical signals from the axon and the other neurons. In perceptrons, these electrical signals are represented by a numerical value. So at the synapses between the dendrites and the axons, the electrical signals are modulated by various amounts. So like similar to that, so this is the weights that is added. Okay, so these are the W0, W1, W2, and these are the weights added to the inputs. Okay, maybe we want to find if it is a sunflower or not. Okay, so what happens? The maximum amount of weight is given to maybe x1 is a sunflower image. Okay, so the maximum amount of weight is given to the sunflower to the value x1. Okay, so when it comes as a weighted sum out of it, then it helps the model understand that this is basically a sunflower. That x1 input that we have given is a sunflower. Okay, so there is much more to that, I guess, but I cannot cover that actually. Yeah. So
there are multiple input is there.
yes, we see. See, suppose there is x1 maybe a sunflower, x2 maybe a daisy, x3 maybe a rose. Okay, now you have given an input to the model that I want to find a sunflower. So what the model will do is like it will put the maximum weight on the x1 value, so that when it comes out, it says like okay, the model is 99% sure that this is a sunflower. Okay, or 98, whatever the percentage may be, sure that this is. But before that, you have to train the model on all the data set. You have to make them understand like where to give the maximum weight. Okay, so that is the process in between done by a function. There are a lot of functions in Python you can do that way.
Why you are taking first one as a constant? First one.
First one as a constant is because there is like even I don't know that why it is taken as a constant, but maybe this is because like one data is taken as a like one value as a flower. That's it. Maybe the constant is basically there. Basically, I have no idea why it is there. Okay. So moving on. Before we move on to computer vision, it's better if I show you the example what I was talking about. Right. So basically, this is the code. Maybe I can share this with you later. So there are 3,700 photos of flowers, basically. Okay. So there is daisy, dandelion, roses, sunflower, tulips, everything. Okay. So for the sake of time, I have already downloaded and everything I have run already. I'll just show you the responses. What it is. Okay. So this step basically we are downloading the whole data set. Okay, and this is the path basically where I've given. So it is downloaded. Now here we are converting it into a list, or you can consider it as an array if you have heard like that. So we considered it as an array. Now we will see like how many what thing we have. Like see, this is a labeled data set. How can I tell? Because as soon as I say like find out roses, it found me one rose at least. So roses from the first rose photo, it found me out the first rose photo. Okay. Then from there maybe we can find one more rose. The next one also is the rose we found out. Okay. So we can find out more tulips as well. So this is first tulips and like this. Okay. So now we will be making one like model. Basically, we'll make one model. We'll train the data set. We'll see what happens. Okay. So we'll split means the data set into a training set and a validation set. Okay. So the training set is basically we'll put at 80% of training set, and the rest we will put it as a validation set. So we have taken a model, we have split it into point two. Basically, 80% will go to the training set and the rest 20% as a validation set. So here we can see that this is taken for training, okay, and here we can see this is taken for validation. Okay. Next, see, so we want to see what are the names. See, this is what I was talking about. See, daisy, dandelion, roses, sunflower, or tulips. These are what we call labels. Basically. So it's already labeled. That means this is a supervised learning, what we are talking about. Okay. So then, okay. So basically, these are some photos we are just showing, like what are the photos one by one. Maybe we have shown this. Okay. Okay. So now we are training the data set. Okay, and we are validating the data set as well. Okay. After that, this is not important. Here we are using a sequential model to train the whole data set on it. So we have compiled the model, we are running the model, and then for 10 times we were running the same algorithm 10 times in between. So each data is running through 10 elements, same algorithm 10 times in a row. So now we will find out the accuracy and everything of the what happened. Okay, so the blue line indicates the training accuracy. You see, the training accuracy is very high, basically.
Tell me what is the purpose of producing training and validation data.
Okay, so you have a complete data set, right? So now how will you tell the model that you are that this is a sunflower and this is a not tulips? So we have a labeled data set that says like photos. These photos come under like dandelion data set. So dandelion, it is mentioned as dandelion, and then it says like these are the 10 photos of dandelions. Okay. So the computer sees that okay. So for dandelion, I can see that these photos are from dandelions, or like these 10 photos are from tulips. Okay. So this is what we call as training set. Okay. Now,
what is the actual meaning of training?
Training means you are making the model understand like which photo belongs to which category. Okay, because this is the supervised training.
Category is different.
Hmm?
Category means that is a different part. Actual meaning of training.
Actual meaning of training. That's what I said. I guess.
My case is not this time.
Huh?
You think about the 10-year back case. Which types of case? After 10 years.
No, that is what. Huh.
So if the computer analyze the back 10 years and after 10 years, according to this data, that is the part of training data. वो एनालाइज करता है
Yes. So
क्योंकि एक्सपीरियंस ही हमारा लर्निंग पार्ट ऑफ एक्सपीरियंस.
What? Yes, I understand. What you are talking about is actually predicting. Okay.
मैंने कहा एक ऐसा प्रोग्राम का यूज करते हैं जो निश्चित रूप से कैरियर बैक का एक फिगर देगा.
Again,
देगा प्रेडिक्ट करना एक अलग चीज होता है. देगा नहीं देगा कोई मतलब नहीं है.
Again, I think you are talking about prediction. According to me, I think
part prediction.
So before before prediction, you have to tell your face. You have to tell the specifications of the face, right? Correct.
And it buys the last.
Correct.
That is part of the page. Other, if it's not successful, that is optimized.
Okay. Noted. Noted. So I understand what you are saying.
हम जब कहते हैं कि हम ट्रेन कर रहे हैं, किसी बच्चे को ट्रेनिंग दे रहे हैं,
हाँ.
क्या करते हैं?
हाँ.
है हमारे पास, उससे रिलेटेड आगे लेके चलते हैं. And that is the part of training.
See, according to me, training is like you are teaching somebody that this is this thing and this is that thing. But you cannot.
बात करते ट्रेनिंग की बात. ट्रेन.
Okay.
Meaning of this. और जब हम कहते हैं ऑप्टिमाइज, बट इट इज नॉट पॉसिबल, ये भी पॉसिबल. ऑप्टिमाइज का मतलब यही होता है.
Okay. 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 So see, as you can see, this is that on the training set, it has paired very well. Basically, the accuracy of the model was very good. Okay. But when it
validation means every data.
Not validation. Just I said the whole data set was divided into 80 and 20%. Okay. So 80% of the data was used in training, and the 20% what we did was the model now understands that this flower is a dandelion. So that 20 other photos we were showing it to the model that whether it understands or not. Okay. Like, do you understand that this flower is a dandelion or not? So that is what I call is a validation. So when it came to that, the model could not understand that. No, I did not understand that this is a validation. That's why you see the orange line is so less. So it could not understand why this happened. Like, why did this stage come? Why you see like training set it understood. Training set it says like, yeah, I understand what is a dandelion. But when it came to like unknown thing and you are showing the model like, do you know this is the dandelion or not? Then it's saying, no, I don't think this is a dandelion, but it's actually a picture of a dandelion. So why it could not understand? This process, we can explain it what we call as overfitting, basically. Okay. So overfitting happens when like the data size is very small. So maybe we have a very less amount of data points, and that is why it could not understand when we try to generalize it. Okay. It only understands the training set. It only understands. Now, within the 80%, if you show him again, it will identify within that 80% that we trained on. Okay. Now, when we show him any other different random picture, it cannot understand. Okay. So this is what happens. So what it needs, what the model needs is more data. Give me more data. But we cannot get more data, right? So we have a limited amount of data, and we have to train it in that only. Okay. So what we can do is we can give him more data. How can we give more data? One example is data augmentation. So data augmentation is a process. What it does is basically there is a image of a tulip. What it does, it creates a mirror image of it. So now we have two images of a tulip. Now it understands that okay, there are two images of a tulip. The data size increases. Maybe invert it. Maybe make a mirror image out of it as well. So basically, we have data augmented these pictures and see like this. So this gives a mirror image and increases the data set. Okay. There's one more method we can use is dropout. Dropout basically it removes few of the like it is getting input and it is getting output. It drops few of the output so that it remains limited to that amount of inputs only. So after we did this, we are again calculating everything. We again train the model on those extra amount of data and everything, and we see the accuracy value has increased. So this is what we use. So let me give you one example. We have done it in Tata Steel basically is what we have a rhomboid slabs that are coming out that are like square faced basically. So any change in shape will cause a production loss basically for us. So what we do, we check for the diagonals. Okay. So in image processing, we find out which are the four diagonals and we calculate those diagonal. We calculate the length of those diagonals and we identify whether instead of a square billet, we've got a rhombus billet or not. Okay. So this is one example. There are hell lot of examples of it. Okay. So now we will show the model, a picture of a sunflower, and we'll see how accurately it tells whether it is a sunflower or not. Okay. So here we can see that we have taken a image of a sunflower, and then excuse me. Then we have asked the model to predict whether do you understand whether it is a sunflower or not. So it says that the image most likely belongs 99.94% confidence that it is a sun. So basically that is this is basically a simple example we have used. The applications that we use in data state is much more complex.
So first of all, we have to train the data.
Yes.
To give for validation.
You have to tell the model first that what you want basically. Okay. So you have to tell them that this is a dandelion, this is a flower, this is first you have to tell him this is a flower. In flower, this is a dandelion. Again, decision tree will come in that. Okay, but we are not using that here. We are only telling them, okay, this is a dandelion flower. These 10 pictures are image of a dandelion flower. Okay. But you need more data, not 10. You have to
Getting our
again you have to go more. You have to give him 100 images of that so that it understands that these are the dandelion pictures. Then it can generalize basically. The more data you give, the more it can generalize. The less data you give, it will be only limited to the training set. Any other different kind of images you show him, cannot understand. So first, what we can summarize is basically like you have to train the data set first. You have to train with the data set. First, split the data set. Whatever data set you have, split it into two parts. One is the training set, one is the validation set. With the training set, you train the model. You tell the model that these are these things, these are that, this is that. Okay. Then you tell the validation model. From the validation, you try to find out like, do the model now understands that this is a tulip or whatever flower or a car, whatever it is. Okay. Once it comes to know that, once you see that the accuracy is high enough, then you can move on with that model. But to get that accuracy and to get that amount of data, you need a lot of time. You need to train every day. You need to train until the model understands. So it's a long process. Basically. Okay. So basically, I can show you few more examples. Maybe this is what is called as PP detection system. Okay, I guess this was explained by Vasant sir. So basically, what happens is this is a simple CCTV camera. You can take a CCTV camera, get a video analysis, and within that video analysis, you can simply find like whether a person is wearing a vest or not, whether the safety helmet is there or not, safety goggle is there. Okay. So basically, it checks for it and then a simple CCTV camera only you can check. Okay. Right. So this is one example. We have done one more example is fire detection. Okay. So fire camera. We have fire detectors, alarms. That is good enough for us. But few places we cannot install these fire hazards or these things. So what we can do is via video analysis we can find out. If there is smoke coming out, it is detecting that there is some smoke coming out or there is some fire. But how did it get to the point that it knows that this is a fire? Again, we have to train the model. You have to train it. You have to make him understand that this kind of image means this is a fire thing. So then only the model will predict that yes, this is the fire and I need to alert. There is one very interesting thing. I don't know. I cannot show it here. It is proprietary of Tata Steel basically. What we have done is we have performed a virtual tour basically of the whole Tata Steel by VR using VR. So what we have taken is we have taken a drone, and with that drone we have like taken images of every plant area or everywhere we have taken an image, and we have stitched those images into forming a whole Tata Steel plant. Okay, so basically now from at home only, if you have a VR machine, you can just put on and you can experience the whole Tata Steel uh, from your home. It's kind of like this. So this is Toyota showroom basically. So this is basically the showing the whole plant basically. Can you the tour of the whole plant? Your viewers. Okay. Uh, Maybe you can move on to the slide. So this is what we showed you just now. Basically, how can you like classify whether it is a cat or a dog, or how will you understand whether it is a cat or okay? So basically, there are these layers that are shown in between here is what filters basically the image from the image points to the point that it shows that yes, it is a cat or it is a dog or not. These are some examples where you can also see like segmentation and localization, object detection, and image segmentation as well. In industrial automation, we can use it in lot of places. Maybe process automation, safety, logistics, data analysis, analytics, and quality inspection. So process automation, predictive maintenance, maybe tomorrow we can talk about it a little bit more. What is predictive maintenance and how IoT helps in predictive maintenance. So one example I gave just now is how you get sensor data from the motor, and from that vibration analysis or the acoustic analysis you can tell whether this motor needs maintenance or not. Okay. Safety, I showed you the PPE detection system, and there are lot of right. So you can see the whether their people have wear helmets or not, whether they have ear muffs or not, or the eye goggles or not. Okay. So basically, you can find it via for safety by using AI or computer vision from here. Okay. Similarly, for this also, like the fire detection, also you can find it out. Okay, for logistics, basically we have something called as yard management. Basically, for logistics we have yard management. So we get a lot of raw materials in our yard. Okay, so what we do is we put cameras everywhere and we find out the amount of coal we got maybe, or the amount of iron ore we have, the other raw materials, limestones, whatever is there. So we find out from there. Okay, so this is one part where we use. So in quality inspection, also we can use it. Maybe there is some hole in one of the steel sheets. Okay, how will we identify? Okay, so we can identify it via image processing as well. There are also electromagnetic ways you can test, like eddy current testing. Also you can do. But apart from that, image processing also we use to detect the surface inspection system we have at Tata Steel. It inspects the surfaces of the steel sheets, whether it has any holes, whether it has any deformity or not. We can find out. Okay. So I guess yeah, I guess we have come to the end of the slide. Do you have any questions? You can.
So in whatever model you have said that taking the cat or dog. So I heard previously that in NLP also there is a large number of data.
Yes, you can do that with
like we have large number of data sets. We are just comparing, right? Whether it is matching 60% to 40%. So that is also using some model like ANN or ANN.
Yes. You were saying?
So is it NLP is also using the same ANN or KNN?
This I have to check and let you know. For NLP, I have little knowledge about it. I haven't used it also.
So ML is still a subset of AI, right? So why we are always talking that AI and ML? Why we are talking
See, that is the wrong notion we have basically to talk on the same terms as AI and ML. So AI is a very broader. AI contains everything.
superset?
Yes, everything. It's a superset. So it contains ML also. It contains computer vision also. We actually take computer vision. What is PT detection we have done? People consider it as AI also. Yes, it is an AI because it's a part of AI only. Computer vision is part of AI only. But it's wrong to say it as an AI because a lot of things come under it. Cannot cover everything.
More question? Okay, for basic actually, there are many question actually, including myself. So is there any way how I can learn about this field, AI and ML, which is the emerging field?
See, AI and ML, I would suggest basically to start with, TensorFlow, and I'll give you that code, the Jupyter notebook I'll provide you. Okay, that contains all the links and the guides where you can start from basically to learn AI and ML basically. Okay, I have included all those. So basically, this is actually what I showed you was a basic how you can train a model to tell them how whether it is a flower or not. You can do it with any data. Even I'll tell you for a chatbot also, you can make a simple chatbot out of nothing basically. All you need is a JSON file. In the JSON file, you will give them inputs and outputs. Okay, so you will give them keywords and the response for those keywords. Okay, you train your model. Simple, you make a linear regression model out of it. Linear regression model. You tell them that yes, I for this keyword, if you find this keyword, you give this response. Again, I'll tell you, the lesser the amount of data, again it cannot generate because I made it myself. What happened was when I was asking him some other thing, asking the chatbot another thing, could not answer. Cannot find the answer because
it is automatically that accuracy is just there is some people threshold for accuracy that you will realize that no, this is less, like 50% or 60%.
No. Accuracy is less. You can understand from the model how confident it is. Basically, how confident are you in the model itself? You will find from that accuracy.
Like there are 99.9.
99.9% is a different thing. That is accuracy. Okay, what I am telling is
graph of
model. Model will tell you that okay, my training valuation, my loss was more. I could only give 50%. I am 50% confident that my training is complete. Then when you ask him, it will tell you like if the previous example we saw, no, if we check whether it is a sunflower or not, it will say like he is 70% confident that this is a dandelion, not a rose or this is a rose or something. After we gave him with data augmentation and everything, after we completed everything, then it become 99.9 sure that.
That means training data should be higher than the
more. We increase the training data set, your model will become more confident. Seems like I know more than what I knew before, basically. Your model.
So already models will be there at last.
Model are there. See, model basically Python, everything has a model already built in. See, what I used was a sequential model basically. That is already a built-in model. See, if you want to learn more about sequential model, you have to go inside. You have to find out what a sequential model does. This is a different extension. This is a whole mathematical formula. So you have to, if you want to go deep, you are more than welcome. But you have to go into statistics and everything. That is there. Any more questions? Huh? Sorry. SVM. Support vector machine. So what support vector machine does is, okay, again, I haven't worked with that most of the time, but what SVM does is basically, you know how it differentiates, it creates a plane in between, like these are that kind of data, these are this kind of data. basically separates by drawing a line out. So that's what support vector machine does.
So finally, AI really it's revolutionize. I mean, it's totally replace. I think in the future it will also replace the sensor. Like in the fire detection case, we are saying that we are using only
Yes, again, but then if you are not using sensors, you have to use cameras. So a input is required anyway. Either you use sensors or you use cameras, however you want. But you can use AI after you get the data. You can use it. Before that, you need to get the data. How will you get the data? You need a level one system for that. Level one system, sensors and everything is should be there. Otherwise, you cannot.
Well, Tata is still nowadays camera is just.
Camera we have everywhere. We have camera. Every movement that is made is checked via camera. So camera is there, sensors we have the data, you can use it.
Thank you, sir.
Thank you.
So he'll be taking his next session tomorrow at the same time. Okay. And same time बाकी आपको डिनर भी वही सेम टाइम पे है, ब्रेकफास्ट भी सेम टाइम पे है, जो भी आपका शेड्यूल चल रहा है वैसे रहेगा. ठीक है. प्रोफेसर्स विल बी लाइक कल आरके जैन सर आएंगे मॉर्निंग में. देन आपका शेड्यूल वैसे ही है. शेड्यूल सेकंड हाफ में भी प्रोफेसर है, मैंने शेड्यूल आपको सेंड किया, एक बार चेक कर लीजिएगा. एंड देन थर्ड हाफ में सर है. सेकंड हाफ में भी आरके जैन सर का उनके रिसर्च थोड़ा सा इतना एक्सपेंडेड है, उन्होंने रिक्वेस्ट किया हमें कि हमें एक और सेशन चाहिए. तो विल ट्राई कि फर्स्ट एंड सेकंड स्लॉट उन्हीं को हमने अलॉट किया है. एंड जो कल जो और एक स्लॉट थे उनको हम शिफ्ट किए हैं, वो हम आपको बाद में बता देंगे अपडेट. सो फॉर नाउ आरके जैन सर का ही 2 सेशन कल रहेगा. क्या आइएगा, उनसे भी बहुत कुछ सीखने को मिलेगा. ही इज फ्रॉम CSIR दुर्गापुर. ओके. तो उनसे भी सीखने को मिलेगा. थर्ड सेशन सर का ही हैंड्स ऑन ट्रेनिंग सेशन रहेगा. ठीक है. IoT बेस पे, IoT टॉपिक पे. ठीक है. IoT बेसिक्स पे. तो कल का दिन भी पूरा एंटरटेनिंग होने वाला है. आप लोग अपना टाइम एंड लाइक टाइम से आप लोग आ जाइएगा और किसी जगह पे आप होगा. ठीक है. कुछ टेक्निकल प्रॉब्लम्स आ रहे थे सुबह से, उसके लिए सॉरी, बट अब नहीं आएगा बिकॉज अब हमने सब कुछ सॉर्ट आउट कर लिया. थैंक यू. आप लोग अपने स्नैक्स ले सकते हैं. ठीक है. उसके बाद आप लोग रेस्ट कर सकते हो. थैंक यू. तो इसमें नहीं सबने साइन कर दिया है, कोई छूटा है? तो सर्टिफिकेट उसी बेसिस पे इशू होगा. सबने किया है. ठीक है. अब नहीं कर दिया.